Hi guys, this lesson today is going to be an exciting lesson because we finally get to learn how to solve equations. We've been talking about logarithms and all these things and how you create them and how you come up with them, and today we're finally going to learn how to solve an equation that requires a log. So here's an example. We had this example a couple of lessons ago. You invest some money in BlackBerry, which if you don't know anything about BlackBerry is not a very good investment. The stock proceeds to lose 5% every month. If the stock continues to decline at this rate, how much money will your stock be worth in 12 months? So we're going to use this equation. We're going to plug in this information. So we start with $2,500, and then we are losing 5% every month, so it's 1 minus 0.05, and we're asking about 12 months later. We can put this directly into our calculator and solve it. Take a second right now in your calculator to do that. All right, you should have gotten $1,350.90. Now this next question is the one that we haven't been able to do. And so what we had been doing is just putting this as an X right here into our calculator and going to the table and scrolling down and seeing when it reaches a certain amount. But now we know how to solve this. After how many months will your stock be worth $1,000? In other words, we want the 1,000 over here on the left, and we have a 0.95 because that's, we start with 2,500, we're losing 5%, so that's 95%, and then the x. We now know how to solve for this x. What we need to do is isolate our exponent. So we need to divide by 2,500. And so we get 0.4 is equal to 0.95 to the x power. I'm going to come over here. So again, we had 0.4 is equal to 0.95 to the x power. We now know how to solve this. We can solve this with logs. What I would do is I would just go left, right, left, or in this case, right, left, right. The base is 0.95, so I would say log base 0.95 of 0.4 is equal to x. And again, we know how to do that on our calculator. So now we can go into our calculator, go to that log base button, and plug this in. Take a second to try that. I'm going to show you on my calculator in case you forgot how. Okay, the way we find that log base button is we go to the math button and then we scroll up 2, and that gets us to the log base. So we hit enter, and we were doing log base 0.95 of 0.4. And when we do that, we got 17.86. Okay, doesn't that feel good to finally get an actual answer? Because it used to be we went to the table and we scrolled through and we'd have to say, well, somewhere between 17 and 18. I don't really know where it is, but that's where it is, somewhere between 17 and 18. And now we have an actual answer, 17.86 months. We have an exact answer, which is, for people involved in math, that's very satisfying. So we finally have that. Okay, let's talk about another thing. We have that log base button. Most of us have that log base button on our calculator. Some of you don't. If you have an older calculator, you actually don't have that log base button, and you might have been looking through it for the past couple of days. Sorry, but those people with older calculators don't have it. But you can still find the answer because there is this formula called the change of base formula. And it's helpful in doing computations, but it's also helpful in solving equations that we'll see along the way. So the change of base formula, the way I remember it, is the big number goes on the top, the little number goes on the bottom. So, and also the little numbers are kind of already down below, so you remember it's down below. Anyway, if you plug those into your calculator, that will give you the same answer. So you might take a second right now just to check it and see what you come up with. Okay, so I put this into my calculator. You can see that log base 5 of 20 is the same as a log of 20 divided by the log of 5. They came up with the exact same answer. So that's just another way. If you don't have that on your calculator, you can always do it this way. And like I said, there will be times when that might be a method that we can use to solve equations. All right, let's get into solving equations. How do we solve equations? There are several methods, and it just depends on how the problem is set up. One method is to create the same base. So we've done this a little bit before when we had some rational exponents, but in this case, 27 is 3 to the third. And so if we change that base, then we have them both in the same base, and then we can just say that 3x is equal to x plus 5. Because what you're doing is you're essentially canceling out that big 3. What you're really doing is taking the log base 3 of both sides, and when you take log base 3 of both sides, those cancel, but sometimes we call this the one-to-one property. So now we just have to solve that, finish solving that out, and that's just going to be 2x equals 5, and so x equals 5 over 2. So if you can create the same base, that's one way to solve it. We would do that same thing over here. I just did this example for you. Why don't you pause here and try to do this one on your own? Okay, 16 is 2 to the 4th power, so I can make this 2 to the 4th to the x, so that means x minus 7 is equal to 4x, and I just solve that and I get negative 7 over 3. Okay, that is one way to do it. However, that does not always work because some things don't always have a common base, so you can't always do it that way. We're going to look at some different ways to do it. One thing is you want to isolate your exponent or log or whatever it is. In this case, they're exponents. We want to isolate that exponent. So in other words, we want to subtract 2 from both sides. Also, another thing is, I don't even know if you remember this, but negatives and logs are problematic. We have a domain issue when we have negatives with logs. So let's divide by -1 or multiply by -1 and get that negative gone. I have 3 methods that I'm going to do. You might notice these 3 equations are the exact same equations because I'm going to show you 3 different ways to solve it. So one way is to go left, right, left. In other words, 7, no, this is already an exponential. We have to go to log. So we're going to go to log base 7 of 18 is equal to 3x. And so now we would need to go to our calculator, find out what the log base 7 of 18 is, and that is 1.485. I put approximately equal to because it is a decimal, right? So that's just approximation. Now I'm going to divide by 3 and find out what my answer is. And so we get 0.495 is approximately equal to x. Okay, so again, what I want to do is go through a couple different ways to show you. So this is one way, is by going left, right, left, changing it to a log, and solving it. Another way to do it is to take the log base of both sides. Well, once again, we're going to have to isolate. So we're going to subtract 2, we're going to make it positive. So let's just jump in there where we have 7 to the 3x is equal to 18. Now, we need to take the log base of both sides. Well, log base what? Well, the base here is 7. And remember that exponents and logs are inverses of each other. And so because exponents and logs are inverses, they essentially cancel each other out. And this gives us just a 3x, a big 3x. And on the right-hand side, I'm taking the log base 7 of 18. All right, now at this point, I can put this into my calculator. Again, I would get 1.485. And then I divide it by 3, and I get 0.495. And those should be approximately equal to. Just going back to show you, there's 2 different methods. They sure look a lot alike, don't they? And honestly, when I'm grading these as a teacher, it's hard for me to tell which method you did. Sometimes I just have to ask you because the work of it looks so similar. The other method is to use that change of base formula, this formula up here. So once again, I'm going to get it set up just like it was, where I get 7 to the 3x is equal to 18. But then when I change it over to log form, I'm going to change it to the change of base formula. So in other words, I set it up like this, and again, that looks very similar to some of the other ones I've had along the way. But now what I'm going to do on the left-hand side is I'm going to make this the log of 18 over the log of 7 and say that that is 3x. And then again, I'm going to go to my calculator, I'm going to get these decimals. The decimal values are going to be the same, and I'll get the same answer. And so again, I get the 1.485, I divide by 3, and I get 0.495. My point in this is there are many ways that you can go about solving it. I'm trying to show you a variety so that you have some tools that you can choose from. Because different people will use different ones, and sometimes you use a different one in different situations. All right, we did those problems, and those were log base 7 problems. When we have an E, do you remember what log base we are in? We're in log base E, which means natural log. So once again, I can go left, right, left, and I can change this over. When I do that, actually, I'm going to go right, left, right. It's going to be the natural log of 24 is equal to x plus 1. I changed it just like I did here. I changed it to exponential form. When we talk about E, we're talking about natural log. So the natural log of 24 is equal to x plus 1. And so now, again, I'll put this on my calculator. I'll see what I get from the natural log of 24. And so I get 3.178 on my calculator. I subtract that 1, and so my final answer is 2.178. Again, I'm trying to show you a variety, so I'm going to do it again a couple. Actually, we're not going to do part C on this one, but we will do part B. So the other way would be to take the natural log of both sides. Taking the natural log is an operation, just like squaring something is an operation, or square rooting something is an operation. You can take that log of both sides. And so that's what we're doing here. We're taking the natural log of both sides. Okay, similar logic to up here. The natural log and the e are inverses of each other, and so that cancels down to x plus 1, and it's a big x plus 1. Then on our calculator, we can figure the natural log of 24. And so when we do that, again, we get 3.178, subtract the 1, 2.178. Let's turn the page. Okay, this property, I cut and paste this out of our Big Ideas textbook. They are calling it the property of equality. This is also similar to the one I was talking about a minute ago that was the one-to-one property, but it's the same concept. The difference, I guess, would be the one-to-one property is with exponents, and this is with logs. So in other words, since we're taking the natural log of both sides, couldn't we really just drop off the natural log? I mean, they're the same thing, right? So we can just drop that off. Now, you can't cancel a log like you cancel a fraction. That's not what we're doing. We just basically skipped a step. We are taking e to the power of both sides, and we'll talk about that in a minute. But the point is, you can drop it off. If they're the same base, you can drop it off. And so now I have a really easy equation that I can solve. And so I get 11 over 2. All right, similar here. Again, they have to be the same base. If they're not the same base, it's not going to work. If this was like log base 7 and this was log base 3, it would not work. But this is going to be the same method as the last one. And so we get negative 6 over 5. This changing back and forth from log to exponent is a common method. So we are going to do that as well. So in other words, I'm going to go left, right, left. It's going to be 2 to the third is equal to 5x minus 17. Now I know in my head or in my calculator what 2 to the third is. It's 8. And now I just need to solve the equation. And so 25 is equal to 5x. 5 is equal to x. All right, similar thing here. It's just this is the natural log. So that means this is e to the 9th. Remember, a natural log is implying there's an e in there somewhere. I'm going to go to my calculator. I'm going to find out what is the decimal value for e to the 9th. Or I could divide by 5 first. So I could get an exact answer like this. You know, sometimes tests ask you for exact answers and sometimes ask you for decimal answers. So if you give an exact answer, this would be it. But if you give a decimal answer, you'd come up with 1,620.62. Make sure you've tried that on your calculator. You know how to do that. Okay, this next method is really cool, I think, personally. I think this is a cool word, exponentiate. What it means is, like I was saying a minute ago, you can take the log of both sides, you can take the square root of both sides, you can also take the power of, you can exponentiate both sides. In other words, we turn this into the exponent. So this is base 2, right? So I can put like a big 2 on both sides. And now what I'm saying is 2 to the power of log base 2 of 5x minus 17 is equal to 2 to the third. And the benefit of that is we've been talking about the log base 2 and the exponent are inverses of each other, and so they cancel out. And so what we get is 5x minus 17 is equal to 2 to the third. And again, we'll make that 8, and then we will solve it. And that can play out with natural logs. It can play out with common logs. For the common log, remember this is a base 10, right? So I'm going to take 10 to this power is equal to 10 to this power. And on the left-hand side, the log and the 10 to the power are going to cancel each other out. And on the right-hand side, I'm going to get 10 to the fifth. And now I just have to solve this problem. I'm going to subtract 1 and divide by 3. Okay, on this lesson today, we just did logs that were like pretty simple. They had logs on one side, or there were logs on both sides, but they were just one log on both sides. The next day, we'll talk about what do you do if you have more than one log involved. But take a few minutes to summarize some things and then give the assignments a try.